Triangles, the polygon that has the fewest amount of sides possible. And we take for granted that its area is equal to its base times height divided by 2. But what if it's not? What if the world suddenly forgot that the formula for the area of a triangle is base times height divided by 2? Is there another way of finding it? Well, there are other ways of finding the area of a triangle, but let's say that knowledge was suddenly lost. How do we find the area? Obviously, just copy the triangle and arrange the pieces to create a rectangular shape. That's a valid way, but that is boring. Let's say humanity forgot that as well. What should humanity do? Okay, before I present my solution, I want you, the viewer, to try it yourself. There are multiple solutions to this and it never hurts to try. However, be aware of invalid proofs. A proof is invalid if it assumes the thing we want to prove is a fact. It's also invalid if humanity knew something that it was supposed to forget. Okay? Pause now if you want to try the problem. Done? Okay, so now I will present my solution. To start off, I want to find the value of the following infinite series. 1/4 plus 1/16 plus 1 over 32 and so on ad infinitum. It follows the pattern of 1 over 2 to the power of n, wherein n starts at 2, then increases by 1 every next term. I promise this will be related to our triangle. From here on out, the manipulations I will make will hinge on this series being convergent. Convergent just means that it does not blow up to infinity like the divergent series 1 plus 1 plus 1 plus 1 and so on. I leave it to you why the series we're interested in is convergent. Since it is not infinite, we can assume that it has a value, x. The next thing we want to do is to multiply both sides by 2. Okay, see these terms? There are original sum. So we can substitute it with our x. Simplifying yields the result that x is equal to 1/2. Nice. So how does this apply to the triangle? Well, let us first focus on right triangles. Now, let us label these sides as h for height and b for base. Create a rectangle with the dimensions which are half of those of the triangle. Now, fit it inside of the triangle. I leave it to you why this rectangle always fits for any base and height. Now, we'll do it again on these two smaller triangles, and then to the smaller ones, and so on. As you can see, with more rectangles means more precision in our approximation of the area. To finally find the area, let's find the area of each rectangle. The area of the largest one is base times height divided by 4. Smaller ones have an area of base times height divided by 16, but this time there are 2 of them. One layer smaller, the area of each individual rectangle is base times height divided by 64, but then there are 4 of them. We do this infinitely many times, and then simplifying, we get our series here. I leave it to you once again why this is true. So we now know this guy is 1/2 and voila! We have our equation for the triangle. That's all I want to show you, and that's the end of the video. Or is it? I know. The proof only covers right triangles. But do not worry, as the hard part is already done. The last thing I need to prove is that all triangles can be made up of right triangles. Take a triangle and put it flat on its longest side. Since it is on the longest side, there is no way that the third point is not above it, as shown here. Now put a perpendicular line on that longest side. Perpendicular meaning it is 90 degrees of the other line. Finally, put that line where it intersects the third point, and just like that, it has been split into two right triangles. The proof did not require any specific properties of this specific triangle, so in fact this applies to all triangles, including those with a right angle. We are done. That's all really. Not bluffing this time. And yeah, that's the end of the video. Bye.